Welcome to the Eventuri development bay. Every intake project starts right here. Step one in our development process is to 3D scan the engine bay. That gives us a very accurate way to digitally map the engine bay, giving us reference points, everything we need to visualize and conceptualize the intake design. Once scanning is done, it's layered, it's processed, and then imported into my CAD software. Once the scanning is fully imported into CAD, we begin the conceptualization of the intake design. The intake design starts to take form, but we need lots of other ways of helping us to optimize that design. One of the things we can do for optimization is to use flow dynamics packages. That gives us a way to visualize and actually measure how the airflow will go through the concept. It also gives us an idea of where possible turbulence will be and how to improve laminar flow and uniformity of flow. Once we're happy with how the intake is performing virtually with the flow characteristics, we can then take that virtual model into reality using 3D printing. We have in-house 3D printers which allow us to very quickly and rapidly prototype the intakes. We use a variety of plastics just for fitment and also to use for actual testing within the car. The 3D printed prototypes are then test fitted in the car, which gives us a very accurate way of checking our design in terms of its fit, and also for any clearance issues, things we may have missed in the scan, and to also give us a way to see how the intake looks aesthetically in the engine bay. Once we're happy with the fitment of the 3D printed prototypes, we can take those and go into real-world testing. One of the things we do is flow bench testing, which gives us a very accurate idea of the maximum flow rate possible through the intake. We can compare that with the OEM system to make sure that we're actually making improvements on the flow bench. The next thing we do with the prototypes is to actually take the car on the dyno for performance testing. That also stress tests the intake so that we can analyze any areas of improvement in terms of stress relief, but more importantly, performance testing to make sure it's actually making power as we intend it to. Once all the testing is complete, we have several data points and a multitude of ways to make sure that we're on the right track. We can reiterate the design using all the components we've just analyzed. We get to a final design, and then that final design moves forward into carbon fiber tooling. With the tooling complete, we have our first carbon fiber prototype. This then goes through the full testing routine again: flow bench testing, stress testing, road testing, dyno testing, just to make sure everything is as intended and it coincides with our initial prototype. With all that done, we can then move forward into full carbon fiber production. So that's a very brief rundown of the entire process from the initial scan all the way through to the full production, which is then assembled and then shipped out all over the world.